Imagine for a second that you're sitting in the driver's seat of a silent, sleek electric vehicle. You touch the accelerator, and that instant, neck-snapping torque pins you to the back of your seat. It feels like magic, doesn't it? But what if I told you that the machine underneath you is actually a collection of over 10,000 components, sourced from every corner of the planet, forged in fire, and assembled by robots that move with the precision of a surgeon? Most people see a car. We're going to see the hidden symphony of raw materials and high-stakes engineering that makes the electric revolution possible. We aren't just talking about steel and glass here. We are talking about lithium from the salt flats of Chile, cobalt from the deep mines of the Congo, and magnets made from rare earth elements unearthed in the mountains of Inner Mongolia. Most people never think about this, but to build just one of these machines, the planet has been hollowed out in thousands of places simultaneously. It's a global supply chain that stretches across hundreds of thousands of miles, often moving in silence until it hits the factory floor. And this is where it gets truly extraordinary, because the process of turning raw earth into a high-performance battery is more violent and precise than you could ever imagine. Let's start at the very beginning, in the desolate, blindingly white expanse of the Atacama Desert. Here, giant pumps pull brine from thousands of feet below the surface, rich in lithium concentration. This liquid sits in massive evaporation ponds for up to 18 months, baking under the sun, slowly turning into a concentrated slurry. It is a slow, ancient process, yet feeds the hunger of a multi-billion-dollar industry that demands speed. What happens next when this raw material is shipped halfway across the world to a refining facility is where the stakes reach a fever pitch. Because if the purity isn't at least 99.5%, the entire battery cell will fail. Once that refined lithium, along with nickel and cobalt, arrives at the factory, it is processed into a fine, powdery cathode material. Think about this. You are walking through a facility that looks more like a high-end clean room than a car factory. The air is filtered to a level cleaner than a hospital operating room, because a single speck of dust can cause a microscopic short circuit that destroys the entire battery pack. You feel the tension here. There is no room for human error. If the humidity levels inside this room fluctuate by even a fraction of percent, the entire batch of cathode coating is scrapped instantly, costing millions. Now, watch the slurry as it's coated onto thin rolls of aluminum or copper foil. This machine moves at a staggering speed, coating the foil at a rate of 50 meters per minute. The coated sheets are then sent through a massive drying oven heated to precisely 150 degrees Celsius, or 302 degrees Fahrenheit. You can hear the hum of the rollers and the subtle hiss of the drying process. It's a rhythmic, hypnotic sound, but don't let that fool you. It is a race against time and chemistry. What happens when these sheets are rolled into jelly rolls and packed into cells surprised even the most experienced engineers during the early testing phases? We move into the cell formation stage, where the battery is given its first breath of life. Each cell is charged and discharged in a cycle that lasts for 24 hours under strictly controlled temperatures of 25 degrees Celsius. During this process, a solid electrolyte interface, or SEI, layer forms on the anode. This is the heart of the battery, the invisible barrier that allows ions to flow while preventing the cell from burning itself out. If this layer forms incorrectly, the battery is dead on arrival. It's a silent, invisible battle happening inside thousands of steel canisters at once. And if you listen closely, you can almost feel the static energy in the air. The cells are then tested for energy density and internal resistance, with a rejection rate of less than 0.1%. Those that pass are laser welded together into modules. The speed of these lasers is blinding, firing with a precision of 5 microns. That's thinner than human hair. You see robots maneuvering in a choreographed dance. Their movements so fast they are nearly a blur to the naked eye. Most people never think about the sheer amount of data being processed here. Every single weld is inspected by an AI vision system that compares it to a perfect digital twin in real time. The chassis of the car is being built simultaneously on a different line, using high-pressure die casting. A massive press, exerting over 6,000 tons of force, stamps out giant aluminum sections of the car frame in a single second. It's a sound like a thunderclap, a sudden violent bang that echoes through the entire facility. This replaces dozens of individual welded parts, making the car lighter, stronger, and significantly more efficient. But as the frame comes together, we run into a major hurdle: integrating the battery pack into the structural core of the vehicle without compromising the safety of the passengers. This is where human skill steps in to challenge the machines. While robots handle the heavy lifting and the standardized welding, the final inspection of the interior wiring and the sealing of the chassis requires a human eye. You see workers running their hands over the seams, feeling for the slightest vibration or imperfection that an AI might miss. In these moments, the factory feels almost artisanal. It's a reminder that even in the age of total automation, the final quality gatekeeper still wears a badge with a human name on it. Before any car leaves the building, it undergoes the rain test and the track stress test. The vehicle is bombarded with high-pressure jets of water to ensure an airtight seal, followed by a simulated drive on a vibration platform that mimics 10 years of potholes in just under 2 hours. If the vehicle makes even one rattle, it's pulled off the line for a complete teardown. The pressure to maintain this level of perfection is why factory floors are so quiet. Everyone knows that one mistake here cascades into a global recall. Let's look at the bigger picture. Globally, we are now producing over 15 million electric vehicles every single year, a market valued at over $500 billion. China, Europe, and the United States lead the pack, accounting for nearly 90% of all production. Over 2 million people are employed directly in this sector, and that number is growing every single day. 50 years ago, we were still relying on carburetor-based engines, and today, we are essentially building rolling supercomputers. In the next decade, we expect this reduction to double as battery costs plummet toward the $100 per kilowatt-hour barrier. Did you know that the total energy stored in a single high-end EV battery pack is equivalent to the energy used by an average house for 3 whole days? Or that some of the copper inside your car's motor was likely recycled from a vehicle that was driving on the road 30 years ago? And perhaps most shockingly, the automation level in some of the newest factories has reached 98%, meaning human intervention is almost entirely relegated to logistics and software management. The evolution of the manufacturing process has moved faster in the last 10 years than it did in the entire previous century. We have traveled from the salt flats of the Atacama to the laser welding rooms of a high-tech factory, witnessing the birth of a machine that is changing the face of transportation. It is a journey of thousands of miles and thousands of individual, perfect decisions. As the car rolls off the line, silent and powerful, it is ready to become part of someone's daily life. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.